Okay, and we're back. So we're still working on this Peardeck. The first step to graphing, right, is to identify our y-intercept. So we have y is less than or equal to 1/4 x minus 2. So our y-intercept is this -2. So we start by plotting that point. And our slope is 1/4. So we're going to go up 1 and right 4. Up 1, right 4 to create our line here. We could also go down 1 and left 4 if we wanted to. Down 1 and left 4. That is another way we can create that slope. And then we're going to use the line tool. But before we start to make our line, we notice that our symbol is less than or equal to. So because it has this or equal to part, this line underneath, that is going to be a solid line. But because this is a less than symbol, so I'll just write what this is. Less than or equal to is always going to be solid line shaded below because it's less than. So we use our line tool, connect those, oh wow. There we go. Connect those dots using our line tool. It is a solid line like you see here. And then below we will shade. So these are all of our solutions that are on the line or under the line. I'm just going to fix that really quick. So it asked if the point 0, -2 is a solution. 0, -2 is right here. It's our y-intercept. And because it is a solid line, it is a solution. It can be on the line. If we were to plug this in, we would have -2 less than or equal to 1/4 times 0 minus 2. 1/4 times 0 cancels out, and we just have -2 less than or equal to -2, which of course is true because it is equal to it. Beautiful. When you're all set, push ahead to slide 9 and we will graph another one. Y is greater than -3/2 x minus 1. So again, first step here is our y-intercept is this -1. So we're going to put a dot there. Our slope is -3/2. So we can go down 3 and right 2. Again, down 3 and right 2. Or we could go up 3 and left 2 to go the other direction. Up 3 and left 2. As long as one of the directions is negative, which our negative directions are down and left. So now we have 2, -4. We're going to check that in a second. We see this symbol is what we're working with, which is greater than. Notice there's no or equal to, so that tells us that it's going to be a dashed line. And it's greater, it's bigger, so we're going to shade above. So I'm going to use my line tool to make like a dashed line, just putting some space in between, like so. And then if it is greater and we're shading above, it's going to be above the line, like so. Beautiful. And then it's asking about 2, -4. So 2, -4 is down here. It's actually on the line, but this is a dashed line. So this is going to be false, and we can show you what that looks like with algebra. So if we plug in -4 for y and 2 for x, we get -4 is greater than. The denominator and the numerator of 2's cancel, so we just have -3 minus 1. And that means -4 is greater than -4, which is false. -4 is equal to -4. It's not bigger than -4. So that would be false. Again, because it's a dashed line, if it's on the line, it is not a solution. So when you're ready, push ahead to slide 10. Graph the linear inequality. The first thing we want to do on slide 10, we do want to get it into slope-intercept form. So we want to move this -2x to the other side. And to do that, we do our opposite operation. So we'll add 2x to both sides. Then we just have y is greater than or equal to. We have this 2x, and we have this -4. The -4 is going to be our y-intercept, so we'll start graphing there. And then our slope is 2, which we can think of as 2 over 1. So we're going up 2 over 1, up 2 over 1. And we can make as many points as feels good to be able to create that line. Our symbol is greater than or equal to. So because it has the or equal to part, it is going to be a solid line. So you can make that line nice and solid, like so. And it's greater than, so we're going to shade above. I'm just going to make this a little bigger. Sometimes it's hard to tell what is above the line and what's below the line, and you just got to think about it for a second. But if you're not sure, you can also always plug in a point and test it. So for example, I just got rid of it. Hold on. We have this point 0, -4, which isn't a good point because that is our y-intercept, and that will work. That's going to be true because it's our y-intercept and we have a solid line. But if you weren't sure which one is above and which one is below, I would think of a point 0, 0 is a great point to test because it's super easy to plug in. So we would get 0 is greater than or equal to 2 times 0 minus 4. So 2 times 0 cancels out to 0. So is 0 greater than or equal to -4? Yes. So that means that 0, 0 must be in our shaded section. And we see it is. So that's the above side. So you can always test a point if you're not sure. And that's how you would go and do that. I love plugging in 0, 0. That's always an option if it, works for the scenario. Oops. Okay. Push ahead to slide 11. So again, we want to get this into slope-intercept form first. So we have this positive 3x. So we're going to subtract it from both sides. And then we get y is less than. We have this -3x minus 5. Our y-intercept is -5, so we'll start by plotting that -5. And our slope is -3. So from the y-intercept, we can go down 3 over 1, or we can go up 3, left 1. Up 3, left 1. Perfect, like so. And we see our line that is getting formed. This symbol is a less than symbol, so it's going to be dashed since it's less than. And since it's less than, we're going to shade below. So I'm going to make my dashed line something like this. So doesn't have to be perfect. And shading below, well, we're going to test 1, -9, which would be like here. So if we plug this in, If our x is 1 and our y is -9, we get -9 is less than -3 times 1 minus 5. So is -9 less than -3 minus 5, which is -8. And yes, it is less than. So below this line is going to have that point. So this is our below side. When the line is getting more and more flat, it can be harder to tell what's above or below. So again, test a point if you need to. And when we tested this one, we did get true. So we knew that that side of the shading had to have that point. We have two more we're going to look at. So when you're all set, push ahead to slide 12. Take your time. Pause the video if you need to. There's no rush. Alrighty, so to get this into slope-intercept form, we're going to add this x to both sides first. And then we have 5y is greater than x minus 5. And then we're going to divide both sides by 5. And so we get y is greater than 1/5 x, or x divided by 5, minus 1. 5 divided by 5 is 1. So our y-intercept is a -1, and our slope is up 1 over 5. Up 1 over 5, or down 1, left 5, like so. Here's our line. The symbol that we have is a greater than symbol, so that means it's going to be dashed since there's no or equal to, and it's greater, so we're going to shade above. So we're going to make this dashed line like so. Does not have to be perfect, especially for the dashed lines. They're harder to do. And then we're going to shade above it since it's greater, like so. And then the question says 1, 1. So when we're looking at 1, 1, we see that point right here, which is definitely in the shaded region. So this is true. Yes. We don't have to plug it in. We see that it's in the shaded region, so we're good. That is definitely a solution. Last one on slide 13, push ahead. Last one we're going to graph today. The first thing we're going to do here is subtract this x, because we got to get it into slope-intercept form, which means y is by itself. So we have a -2y is less than a -x plus 6. And then we divide everything by -2. Now we got to be careful with this. This is an important one you want to notice. When you divide by a -2, you flip the sign. Keep, change, flip. Maybe that sounds familiar. Whenever you divide by a negative in an inequality, we flip the sign. So we have y is greater. -x divided by -2 is a positive 1/2 x. 6 divided by -2 is a -3. So our y-intercept is that -3. And our slope is 1/2. So we're going to go up 1 over 2, up 1 over 2, up 1 over 2, or down 1, left 2, down 1, left 2. It is a greater than symbol, so we are going to keep it dashed. And because it's greater, we're going to shade above. So when we make this line, we make it dashed like so. And then we're shading above. So it will look like this. Beautiful. And it asks about the point 5, 0, which is here. I believe that's above the line, so that looks good, but it's really